Nama saya Encik Muhammad Faris bin Abdul Fattah. Nombor metrik B11251055.
Nama saya Wal Muhammad Hakimi bin Wal Muhammad Sunadi. Nombor metrik saya B1125106788.
Nama saya Rektor Sekian Anak Besar. Nombor metrik B11251077.
Nama saya Riza Ashraf. Nombor metrik saya B1125107788.
Assalamualaikum, nama saya Nur Anisa Hubwa Maisara. Nombor metrik saya B1125100743.
Hai, Assalamualaikum, nama saya Puji Diana binti Muhammad Bakhyar. Nombor metrik saya B1125100787.
The system box, capacitor and power supply. So first we are going to measure the resistor. First, in order to measure the resistance, we must make sure that there are no current or power supply active. Turn off the voltage. Okay. Next, we just use this setup. As we can see,
now we're going to measure the inductance. First thing first, we connected our RLC meter to the inductor and set the inductor to 1 Henry. Then turn on our RLC meter and it will show you the inductance value as shown on the video.
First of all, we have to discharge the capacitor. Then we set our multimeter to capacitance mode. Connect the multimeter probes to its terminal and read the value. As you guys can see, we got 10.31.
Now we are measuring voltage of 5 volt through 3 kilo ohm resistor and 5 microfarad capacitor. Our multimeter is showing 0 volt because our capacitor in steady mode, so all the voltage must be through the capacitor, so our multimeter should show 5 volt. Now we are measuring voltage across the resistor. We are using 3 kilo ohm. Our multimeter should show 5 volt also.
So now we are going to measure current. So we open the circuit in resistor box so that we can allow the current through the multimeter to get our reading. So as you can see here, we set into milliammeter with our resistor box in 3 kilo ohm.
How to use a digital multimeter to find a resistor, capacitor, inductor. First, to find a resistor, capacitor, and inductor, we need to make sure there is no power supply on in our circuit. Next, to find our resistor, we can use a digital multimeter and connect it like this and set our digital multimeter into the resistor mode. So you can see we get the same value as our true value. Next, to find a capacitor, we need to take up our capacitor out of our circuit. Next, we need to discharge our capacitor, either connecting with the resistor or using our digital multimeter and connect it into a voltage mode. However, because we don't have any tool to directly measure our capacitor, we can use this setup to find a voltage and current to measure, and then using a formula to find our measure capacitor value. Same as a capacitor, because we don't have any tool to directly measure our inductor, we can use this setup where we find voltage and also current, and then using a formula to find our inductor value, just like this.
Now we are doing simulation using multi-sim. Our I already construct the circuit same as we do in lab. Our voltage is this 5 volt with resistor 3 kilo ohm and capacitor of 5 microF. Now we need to measure the voltage through the resistor. It shown here is 5 nanovolts. I mean there is no voltage crossing this resistor now. This is because our capacitor is in steady mode. Now we change the multimeter to the capacitor side and run the simulation. We should get 5 volt over here. So all the voltage in this circuit already has been absorbed by this capacitor. We are measuring the current throughout the circuit. We are still using 5 volt voltage as a supply and 3 kilo ohm resistor. So our current is 1.661. So in lab we got 1.7 milliampere. This is the same reason the component have the plus minus side.
The conclusion is the value that we got from using multisim is more accurate than in real experiment. This is because in multisim the percentage for error is lower than in experiment. Compared to value that we got from real experiment have some error such as instrument error and human error.